Okay, we're on section 17.3, current and voltage measurements. Instead of sharing the PowerPoint, I kind of made my own little PowerPoint using the iPhone because I wanted to draw on the circuits. Let's see, there we go. Should all right. So you should be seeing the figure. It's a figure 17.5 out of the book on page 571. We're going to talk about current and voltage measurements. On the left side over here, you have a physical circuit. I mean, it's a drawing, but it's showing you how you would wire up a physical circuit. So you've got the batteries here. You've got the resistance is the bulb here. Then you have this is the ammeter. So this and this are the same. And then this is the voltmeter over here. Now, the circuit, it says here that the word circuit means a closed loop of some sort around which current circulates. So if I were to break, let's just, if I were to break the circuit right there, let me make it bigger. If I were to break the circuit there, you would get no flow. There would be no flow. So if I were to break it here, you would get no flow. In other words, you need a closed circuit for the current to flow. Now, if I were to break it here, you wouldn't get a voltage reading, but you would still get current. You would get current going through, out of the battery, through the bulb, through the ammeter, and back to the battery. So you would get current flow. You just wouldn't get any through the voltmeter. And actually, we're not going to be getting much voltage through the voltmeter intentionally. And I'll explain that in a little bit. So there's the circuit, and ammeters. That's this fellow here. The ammeter are intentionally made to have very low resistance so that they don't affect the circuit much. If they had a high resistance, then they become part of the circuit, and you have to take them into account. But they don't. They do have resistance, but they have very low resistance. The voltmeter, or it's actually the same meter, but depending on what mode you have, the voltmeter intentionally has very high resistance, probably on the order of a megohm or more, and that's intentional so that it doesn't affect the circuit. We'll learn later. If it were low, it would be like having a resistor in parallel with the bulb, which would lower the overall resistance. But voltmeters are intentionally made to have a high resistance so that they don't affect the circuit. You don't put them in line. You put them across. You put them in parallel with what you're measuring. Whereas an ammeter, you do put it in line. You can see that it's in line with the bulb, so it becomes part of the circuit, and hopefully the resistance is low enough that you don't that you don't affect the circuit much. Now, a little extra points for those of you that actually watch the video. You have 2.91 volts on the voltmeter. You have 0.835 amps on the current meter. Tell me the resistance of the light bulb. Just put it down on an email and send it to me, and I'll give you extra points. Okay. Let's erase those. I think that's about all I wanted to say about these. We're gonna be doing similar circuits as this um, tomorrow, or well, yeah. By the time you listen to this, it will be Thursday, which we'll watch it on Wednesday, hopefully, and it'll be Thursday. Now, I made my own little. I didn't use the generic picture of a voltmeter that they have in the book because I've tried. I don't know that this is the exact model, but it's very close to the model we have. And this is a multimeter, and you can see that it has several ranges. Um, Over here is our voltmeter. Uh, where that's where you have to put it in range with the whatever your um, reading. If it's very small, you put it in the 200 millivolts. If you put it in 2 volts, we were using 5 volts today in our lab on the RC time constant, but we were using a 5-volt power supply voltage, so the 2 volts was too small, so we went to the 200 volts. So that's the voltage reading. Um, these here are the uh, alternating current voltage readings, the AC current readings. Um, Over here, this is the resistance readings, and over here are the current readings. Now, for voltage readings, well, you always use this common. The black lead always goes there, and if you're using uh, voltage or resistance, you put the red probe over here. If you're using um, current, you use it for, if it's microamps or milliamps, you put the red one over there. If it's um, if it's uh, 20 amps or more, which is a very high current, you have to use this one, and you put the dial over in this area here, okay? Let's get rid of these. And I think that's all I need to say about these multimeters. I put in our particular multimeter. Again, I don't know that it's the exact model. I don't know that we have a 410. Next time we go to the lab, I'll look. If anybody by chance took a photo of the multimeter and see what kind of model it is, let me know. Okay, I think that's it for current and voltage measurements in circuits. We're going to be doing more of this in the lab, but that's it for this section. And I'll upload these instead of the PowerPoint slides that they do have.